Functions, quick thingy. Okay, what is it? Okay, this is a very bad low quality image of my notes, but still works. It's page 69. Okay, it is a mapping between the input and the output relation between two sets. Okay, um so yeah, that's that. You input things, you get things out of it. Okay, a it's just a machine. Okay, yeah, you put in it's like a furnace, or like a microwave, or like a blender. You put in things and you get something else out of it. Okay, and that something else is useful actually. Okay, like getting you a mark or something. uh, I have done the naming, like the thingy here, wrong. Okay, so first you read the function. Okay, like the function heading, then you read inputting functions. Okay, so to input something, when we say input the value something into the function, you just say just substitute that value into the equation of the function. Okay, so here when we say f of 4, we mean we substitute 4 in place of x in the equation that the function relates to. So that's that, and here I have explained it. Example, f of x is this, f of 5 will be this value. Okay, next is you will find this inverse functions. Okay, Cambridge likes these also come in the form of like finding the inverse of a exponential, which we haven't learnt, and I haven't covered, which is my bad. Okay, but I will tell you something. Okay, let's first review inverse functions. What are they? It just is the inverse of the function, the reverse of the function. It reverses the effect of the function. Okay, if you apply the inverse function to the output, you'll get the original input that the output originally came from using the function itself originally. So, yeah, look, I wrote this only one line. I did not explain this. The composite of a function and its inverse is always x, no matter what. If you have f of inverse of x or inverse of f f of x, it will always be x. This is useful for inverse functions, like find the value of x for f inverse is equals to 3. Okay, so how do you do it? You apply f in the function f on both sides, so you cancel out the f inverse and f to get x on one of the hand on one side of the equation, and then on the other side you just simplify, like f of 3 is equal to some value, and boom, you solve the question without needing to use to know how to take the opposite of a exponential. Okay, exponential as in base to the x power something. So here I have explained how do you find the inverse if you are given the function originally. Okay, so the first step is you replace x with y's, and you replace the f of x with x. Okay, like the places I have put y, those are the x originally, and the place I have put x, that is f of x originally. This change of variables, you can do it with something else, like change it, like you set this equation equal to y and then solve for x instead, whatever. Here I taught you that you should replace it with y and replace it with x, and then you do the working. Okay, you solve for y. Okay, and then you just say that this is also is equals to f inverse, which then gets your mark. Okay, the equation that f inverse is, that is what your answer should be. Okay, you should write in the answer space given. Okay, so that is that, inverse functions. Let's do a lot of practice, you'll get used to it. Next is composite functions. These are like a bit rare. Okay, I've okay, but they do come, okay, like they are unpopular, let's say that. Inverse functions and inputting functions, they are overrated. Composite functions, you still need to learn them, okay. These are functions when you apply two functions at once, two different functions at once, two same or two different, okay. So here we have f of g or g of f, fg and f and gf, okay. Gf, it's not girlfriend, it's g, the function g applied on function f applied on x, okay. So yeah, here I explained how the thingy goes. Like you first input f, then input g, then you input f, and then so on, so on, so on. You simplify the equation, and you get the equation, and then you can solve the question further. Okay. And here I told you that f of g and g of f are not same. What does this tell us? That if you change the order of applying the function, it will change the entire function, the entire output differently, okay, entirely. So you cannot swap the order of functions that you do, okay. Next, I have also told in the third line, okay, that if we were to do double, like apply a function on itself again, okay, then we just basically have this f of x and so on, so on, so on. You just basically do the same thing you did with f and g, but with f instead in place of g. And yeah, we can see this thingy going on. This bottom line also explaining that if we, example, plug in 3 on fg and gf, we do not get the same value in the answer, okay. So it is very important to know this fact, okay. And that is functions. Quick recap, okay, on my phone, which is interesting. So if any questions or if any problems arise while doing past papers, okay, then just read the question carefully, what it asks. You may be asked to have a function, solve for when the function is equals to some value. You basically replace the function with the equation that the function represents and then solve for the variable. Or if it says that solve for the f of inverse, and that inverse is like a equation itself, like t plus 2 or 3x or something, example, and then the other stuff equals to some variable, some function, some equation, then you can just replace stuff, whatever. And example, we did learn input functions. If we input 3x instead of normally x, we just replace all the x's with 3x's. And so that's that. If it asks for f of x plus 2, then we replace every x with x plus 2 and keep going. Remember, when we substitute in a quantity like x plus 2 or x 3x plus 7, we always do it in brackets so that we are careful and do it correctly, okay. Always when substituting in thingies, you always want to do it in brackets, okay. Bracket is like a bubble, safety bubble, so you do not mistake anything for anything else, okay. Bye.